Okey, Assalamualaikum dan salam sejahtera. Okey. Okey, Assalamualaikum dan salam sejahtera. Okay, this is a second video for chapter 4. Okay, so this video talking about Taizan response and steady response. And then in this video also to describe the meaning of stability. Okay, and then the last one is a pole and zero. Okay, so ada 3 okay dalam video ni. So hopefully you can manfaatkan video ni dan cuba faham apa yang saya sampaikan. Okay, just imagine macam mana saya ajar awak dalam kelas. Okay, so for Taizan response and steady state response, apa yang perlu tahu adalah apa kat mana Taizan response dan kat mana steady state response. Okay, so the time response of control system consists of 2 parts. Okay, so we call it transient response and then steady state response. But in NICE, okay, transient response called as a natural response, and then steady state response in NICE textbook dipanggil forced response. Okay, so sama je, sama ada NICE, sama ada natural ataupun forced response. Okay, so you can use both. Okay. Okay, transient response, this one maksudnya adalah the system goes, okay, the system goes from the initial state to the final state. So you can see here, okay, from initial to the final state. Okay, this one is transient response ataupun kita panggil dia natural response. Okay. Okay, the second one is a steady state response. Okay, the manner in which the system output behave as a t approach infinity. So maksudnya the system output behave as a t approach infinity. So you can see this figure. Okay, so dia akan approach to t infinity. Okay, dia cuba. Okay, so boleh nampak lah kat sini apa itu Taizan response. Dia cakap kat sini, okay, gradually change of the output from initial to desired condition. Okay, so dia akan ubah daripada initial to desired condition. Okay, and then steady state response approximation to the desired response. Okay, yang lain-lain ni yang nampak steady settling time, and then nampak kat sini ada TP, ada TR ni. Okay, yang ni kita akan belajar next chapter in the second order system. Okay. Okay, so you know the response. Okay, so the system response, okay, CT may be written as here the first term on the right hand side, and then plus dengan the second term. Okay. Okay, this one is a transient response, and then this one is steady state response. Okay, so CT equal CTI plus CSS. Okay, so hopefully you can understand. Okay, so kita ada 2 sahaja, transient and steady state response. Okay, and then dia punya equation. Okay, so kat sini kita nak belajar pasal absolute stability. Kita nak tahu macam mana sistem tu dikatakan absolute, dan kita ada juga kita panggil dia relative stability, and then kita ada steady state error. Okay, steady state error. Error ke error? Error kan, steady state error. Okay, so untuk absolute stability kita ada 2 je. Sama ada kita nak tahu dia stable or unstable. Okay, the idea dia adalah, okay, the system is equilibrium if in the absence of any disturbance or input, the output stays in the same state. So maksudnya kat sini, maksudnya output equal to the input. Okay, walaupun dia ada gangguan ke, ada apa-apalah kan. So dia punya input dengan output sama. Okay. Sama juga dengan yang ni dia cakap kan. Okay. Dia kata a linear time invariant control system is stable if the output eventually come back to its equilibrium state when the system is subjected to an initial condition. Okay, walau macam mana pun keadaan, walau macam mana pun dia punya performance, okay. So kalau output dia equal dengan input, so kita panggil dia stable. Okay. But, okay, this one is a critically stable. Okay. Critically stable if oscillation of the output continue forever. Okay, so yang ni you boleh bayangkan kalau spring lah, kalau kita tarik dia kan macam mana kan. Konsep dia macam itulah. Okay, macam mana pula unstable? Okay, unstable ni happen when the output diverge without bound from its equilibrium state when the system is subjected to initial condition. So maksudnya dia dah out, dia dah tak boleh follow dengan initial. Okay, so itu kita panggil dia unstable. Okay, kita ada juga relative stability. Relative stability dia happen bila the input cannot follow immediately. Okay, but exhibit as a transient response before a steady state can be reached. Okay, so dia macam too longer ke, dia macam tu lah, ambil masa yang lama kan. Tapi akhirnya dia akan cuba untuk follow the desired input juga. Tapi dia tak boleh buat immediately. So so this one kita katakan dia relative stability. Okay, the steady state error. Okay, steady state error happen when the output of system does not exactly agree with the input. Okay, so macam ni lah kan, kalau awak tengok gambar ni kan, okay, dia ada steady state error kat sini. Okay, so maksudnya dia ada gap lah. Okay, okay, so hopefully you dah boleh nampak kat sini macam mana stable, macam mana unstable, macam mana relative stability, and then last one is steady state error. Okay. Okay, next kita nak tahu what is a pole, what is a zero. Okay. Okay, so yang saya dah bagi tahu tadi, okay, dalam buku NAS dia panggil steady state response is forced response. Okay, transient response, natural response. Okay, so natural response also called the homogeneous system. Okay, so macam mana nak dapat dia punya sistem ni in term of transfer function. Okay, so maksudnya first awak kena dapatkan dia punya differential equation, and then lepas tu taking inverse Laplace, and then barulah you akan dapat output response in T domain. Okay, and then you evaluate, and then you can see lah dia punya respon dia macam mana kan. Okay, the concept of pole and zero, fundamental to the analysis and design of control system, simplify the evaluation of system response. Okay, so maksudnya ni adalah the concept pole and zero ni adalah fundamental. Okay, so remember. Okay, so now we want to know what is a pole, what is a zero. Okay, pole, zero. Okay, pole, basically pole ni kita guna cross macam ni, cross, okay. And then pole, dia like circle, tapi yang ni dia macam tak circle. Okay lah, macam dia macam something circle lah kan, tapi tak jadi pula. Okay. Okay, so pole ni, okay, the value of the Laplace transform variable that cause the transfer function to become infinity. Okay, sebab kenapa dia jadi infinity? Sebab pole ni dianggap macam ni lah. Okay, any roots of denominator of the transfer function that are common to roots of the numerator. So maksudnya pole ni adalah denominator. Okay, so denominator ni dia adalah maksud nak jadikan transfer function tu sebagai infinity. Okay, so for the zero, okay, biar selalu kita akan dia punya simbol adalah circle. Okay, the value of the Laplace transform variable S that cause the transfer function to become zero. So maksudnya transfer function equal to zero. This one transfer function equal to infinity. Okay. And use of the numerator, m of the transfer function, they are common to root of denominator. So dia punya 0 adalah numerator. Okay. So hopefully you can you boleh dapat beza lah sekarang kan. Okay. Apa itu 4, apa itu denominator. Okay, for example this one. Okay, you have a simple transfer function. Okay, s plus 2 divided by s multiply s plus 5. Okay. So kalau tengok kat sini, you akan ada satu pole and then 2 zeros. One zero ni, 1 0 and then 2 pole. Okay, s equal 0, s equal minus 5. This one 0, s equal minus 2. Okay, but for these cases, okay, so macam mana, kenapa dia dapat macam ni? Sebab dia punya input adalah start input. Okay, 1 over s. So, and then dia cancel 1 over s tu kan. Masukkan dalam sistem. Okay, so and then bila dia masukkan s tu, dia cancel out. Okay. Maksudnya 1 over s ni adalah dia punya apa orang kata, ni adalah dia punya input. Okay, so dia keluarkan 1 over s. So and then you akan dapatlah 1410. Okay. And then kat sini dia cerita lagi. Okay, so maksudnya this one in term of Laplace, and then for the time response you inversekan dia punya Laplace ni, akhirnya you akan dapatlah Ct equal to divided by 5 plus t over 5 multiply exponential minus 5t. Okay, this one dikata force response, and then this one is a natural response. Okay. Okay, kat sini, okay, a pole of the input function generate the form of the force response. Okay, so maksudnya pole ni, dia akan generate the force response, steady state. Okay. And then, a pole of the transfer function generate the form of the natural response. Okay, so and the second one is a natural response. Kenapa dia natural response? Sebab dia exponential. Okay. A pole on the real axis generate an exponential response of the form exponential minus at, where minus a is the pole location on the real axis. Okay. Thus, the farther to the left of pole is on the negative real axis. Okay, the faster the exponential transient response will decay to 0. Okay, number 4, the 0 and pole generate the amplitude for both the force and natural response. Okay, I think that's all for transient response, steady state response, and pole and 0. Okay. Hopefully you can understand, okay? What is a pole, what is a 0. Okay. Paling penting this one lah, pole and 0. Okay. That's all. Okay, kalau ada apa-apa boleh tanya. Boleh tanya, boleh WhatsApp, boleh apa-apa je. Okay. Janji awak faham.